This time, let us consider the integral of dx over the square of 4x squared plus 9. And you can see that we can have the form u squared plus a squared. Now, according to the specific rule, no, if the integrand contains u squared plus a squared or a squared plus u squared, we will try the substitution u is equal to a tangent of theta. Okay, so we can have the value of a, okay, by letting use a square is equal to 9, okay, in the integrand, no? And if a square is equal to 9, then a is equal to 3, okay? And we will let u square is equal to 4x squared. And if we will get the square root of both sides of the equation, that gives us u is equal to 2x. Okay, so since we will let u is equal to a tangent of theta, then we let u is equal to 2x. So 2x is equal to a is equal to 3 tangent of theta. Okay, we will need x squared and the differential of x. So we can solve for x now by dividing both sides of the equation by 2, which will give us x is equal to 3 over 2 tangent of theta. And if we will get the differential of both sides of the equation, then we have the differential of x is equal to the differential of 3 over 2 tangent of theta, which is equal to 3 over 2 secant square of theta d theta. Okay, now if x is 3 over 2 tangent of theta, or 2x is equal to 3 tangent of theta, then we can also get the square of both sides of the equation here, no? If we have 2x equals 3 tangent of theta, getting the square of both sides of the equation will give us 4x squared is equal to 9 tangent square of theta. So this will be the expression that we will substitute in 4x squared in the integrand. Okay, so let us do the substitution now. We have integral of the differential of x is 3 over 2. Okay, sorry, this must be 3 over 2. Okay, so we will have dx is 3 over 2 secant square of theta d theta, secant square of theta d theta, okay, over, okay, we have quantity 4x squared is 9 tangent square of theta. So we write 9 tangent square of theta, no, to replace 4x squared, then plus 9, okay, and this must be raised to the second power. Okay, and let us try to simplify the integrand. Now, since we have a constant factor in the integrand 3 over 2, then we can write 3 over 2 before the integral sign. So 3 over 2 integral of secant square of theta d theta, no, over, okay, let us try to simplify the denominator. Okay, look at the expression inside the grouping symbol. Okay, there is a common factor 9. So if we will factor out 9, then the other factor is tangent square of theta plus 1. Okay, everything raised to the second power. Okay, now look here. We have 3 over 2 times the integral of secant square of theta d theta in the numerator. And take note that we have the identity that tangent square of theta plus 1 is equal to secant square of theta, right? So we can replace tangent square of theta plus 1 by secant square of theta. Okay, giving us the denominator equal to 9 secant square of theta. Okay, and we have to raise this to the second power. Okay, so what will happen? We have 3 over 2 times the integral of, in the numerator, we have secant square of theta d theta. And what about the denominator? If we will get the square of 9 secant square of theta, then that gives us 81 secant to the fourth of theta. Okay, we can write 1 over 81 before the integral sign, which will give us 3 over 2 times 1 over 81 times the integral of. Okay, now look closely at the integrand. In the numerator, we have secant square of theta, and in the denominator, we have secant to the fourth of theta. Therefore, we can divide the numerator and the denominator by secant square of theta, or we can do cancellation. Okay, we can cancel secant square. Therefore, making the denominator secant square of theta. Hence, the integrand is now in the form d theta over, okay, we have secant square of theta. Okay, and look here. We have 3 over 2 times 1 over 81. Okay, we can divide or we can do cancellation. Okay, we have 3 by 3 will give us 1, 81 by 3 will give us 27, right? And look closely at the integrand. We have d theta over secant square of theta. Of course, this is not integrable in this form, but we know that 1 over secant square of theta is cosine square of theta. Okay, so 1 over, okay, let me use 1 over secant square of theta is equal to cosine square of theta. So if we will use the identity, then this will give us 1 over 54 times the integral of 1 over secant square of theta is cosine square of theta d theta. And in evaluating the integral of cosine square of theta d theta, we have to do transformation. Okay, how do we do the transformation? Since the integrand involves cosine square of theta, then we use the identity that cosine square of theta by half angle identity is equal to 1/2 of 1 plus cosine of 2 theta. Okay, please recall transformation, okay, by trigonometric formula where the exponent of cosine is even. We need to use half angle identity for cosine, and cosine square of theta is 1/2 of 1 plus cosine of 2 theta. Therefore, we have 1 over 54 times the integral of, we replace cosine square of theta by 1/2 of 1 plus cosine of 2 theta, okay, times the differential of theta. And if we will express this as sum of integrals, okay, we have 1 over 54 times 1 over 2 is 1 over 108, right? Okay, so 1 over 108, okay, times the integral of the differential of theta plus 1 over 108 times the integral of cosine of 2 theta d theta. Excuse me for a while. Okay, so to continue, Evaluating the integral of d theta will give us theta. Therefore, we have 1 over 108 times theta, since the integral of the differential of theta is theta. Then plus 1 over 108. Now, to evaluate the integral of cosine of 2 theta d theta, we can use the formula that the integral of cosine of u du is equal to sine of u plus the constant of integration. So here, we will let u is equal to 2 theta, okay, such that the differential of u is 2 d theta. And since we have cosine of 2 theta at 2 theta times the differential of theta, then we can express d theta as du over 2. So that would mean that there is a correction factor 1/2, right? So we multiply this by 1/2, the correction factor. And the integral of cosine of u du is sine of u. So we have sine of 2 theta plus the constant of integration. So the integral is equal to 1 over 108 times theta plus 1 over, okay, 108 times 2 will give us 216, okay, times sine of 2 theta. Okay, well anyway, we can also have this as 1 over 108 na lang. Okay, wait. Let's write it back to 108. And since we have 1/2 here, and sine of 2 theta is 2 sine of theta, cosine of theta, if we will use half angle identity, okay, recall that sine of 2 theta is equal to 2 sine of theta cosine of theta, okay? Why do we need to express this in terms of sine theta cosine of theta? Kasi we are going to refer again to a right triangle whose acute angle is theta. So we need to express sine of 2 theta, no, in terms of sine and cosine with the argument theta. So we have 2 sine of theta cosine of theta plus the constant of integration. And in here, 2 will cancel, okay? Which will give us 1 over 108 times theta plus 1 over 108 times sine of theta cosine of theta plus the constant of integration. Now, there is, of course, a need to substitute back the original variable. And if we will substitute back the original variable, then we will go back again to the substitution 2x is equal to 3 tangent of theta. Now, let me have it here on the other side. So if we have 2x is equal to 3 tangent of theta, if we will solve for tangent of theta, then we need to divide both sides of the equation by 3 so that tangent of theta is 2x over 3. Okay, and if we are going to refer again to a right triangle whose acute angle is theta, okay, let me draw the right triangle with the acute angle theta. Now, by definition, tangent of theta is opposite over adjacent. Now, since tangent of theta is 2x over 3, then the opposite side is 2x and the adjacent side is 3. And if we will determine the measure of the hypotenuse or the value of the hypotenuse, then the hypotenuse is equal to the square root of the square of the sum of the squares of the other two sides, no? Which we will have 4x squared plus 9. Okay, so the hypotenuse is equal to the square root of 4x squared plus 9. Now, what do we need? We need theta, okay? So if we want to get theta, then we get the inverse tangent, no? Okay, we solve for theta, and this is equal to arctangent of 2x plus 3. Okay, so if tangent of theta is 2x over 3, then theta is equal to arctangent of 2x over 3. Okay, what else do we need? We need a value of sine of theta and cosine of theta. Okay, now, sine of theta from the, referring again, rather, uh, referring again to the right triangle, sine is opposite over hypotenuse. The opposite side is 2x. The hypotenuse is square root of 4x squared plus 9. Okay, and what about cosine of theta? Cosine of theta is adjacent. The adjacent side is 3 over the hypotenuse. And the hypotenuse is 4x squared plus 9. Okay, so substituting the values of theta, sine of theta, and cosine of theta, then the integral is equal to 1 over 108, okay, times theta. Theta is arctangent of 2x over 3, so times arctangent of 2x over 3, okay, then plus 1 over 108 times sine of theta is 2x over the square root of 4x squared plus 9. Okay, and cosine of theta is 3 over square root of 4x squared plus 9. Okay, so let us try to simplify. This is equal to 1 over 108 arctangent of 2x over 3. Okay, and on the second term, we can do some cancellation. Okay, we can have 2 and 108. Okay, 108 by 2 will give us 54, right? Okay, and if we have 3 here in the numerator, okay, 54 of course is divisible by 3. Okay, so we can do cancellation again. Okay, 54 by 3 will give us 18, right? Okay, okay, therefore we will have, okay, let me write 18 here para hindi siya, okay, wait. Okay, this will give us 54, and 3 by 54 will give us 18. Okay, so the second term is, okay, in the numerator we have x, okay, over the denominator 18 times, we have here square root of 4x squared plus 9 times the square root of 4x squared plus 9, which is equal to 4x squared plus 9 plus the constant of integration. Okay, so this is the integral of dx over the square of 4x squared plus 9. Okay, and it is equal to 108 times arctangent of 2x over 3, okay, plus x over 18 times the quantity 4x squared plus 9 plus the constant of integration. I hope that you were able to follow the discussion. So just use the suggested substitution that if the integrand involves u squared plus a squared, we try u is equal to a tangent of theta. But of course, we need to identify a squared and u squared first and do the corresponding substitution. Okay, let us now have another example. Okay, this time, we will consider evaluating the integral of the square root of 9x squared minus 16 times the differential of x over x. Now, what do you notice in the integrand? It involves 9x squared minus 16. And we can take it as u squared minus a squared. And according to the rule, if the integrand involves u squared minus a squared, we will try the substitution u is equal to a secant of theta. Okay, so if we will have the substitution u is equal to secant of theta, then we must have the value of u and a. And in the radicand, we have 9x squared minus 16. So we will consider a squared is equal to 16. Getting the square root of both sides of the equation will give us a is equal to 4. And we will consider u squared is equal to 9x squared. Okay, get the square root of both sides. U is equal to 3x. Okay, now, since we will do the substitution, u is equal to a secant of theta, okay, then u, okay, we have u is equal to a secant of theta. U is 3x, right? So 3x is equal to a is 4 secant of theta. Okay, we need also the substitution for x and the differential of x. So we solve for x by dividing both sides of the equation by 3. So that x is equal to 4 over 3 secant of theta. And since we need the differential of x, then we get the differential of both sides. Okay, we have dx on the left member. And on the right member, we have the differential of secant of theta, which is secant of theta, tangent of theta, d theta. So we will have 4 over 3 secant of theta times tangent of theta, d theta. Now, in the integrand, no, we have 9x squared. So let us consider getting the square of both sides of the equation. In 3x is equal to 4 secant of theta. Okay, getting the square of both sides will give us 9x squared is equal to 16 secant square of theta. Okay, so we are now ready for, excuse me, the substitution. This will give us integral of the square root of, okay, we have here 9x squared is 16 secant square of theta, okay, here. Then minus 16, okay, we multiply this by the differential of x, and the differential of x is 4 over 3 secant of theta tangent of theta d theta, okay, over the denominator. Now the denominator is x, and x is, okay, 4/3 secant of theta. So we have 4 over 3 secant of theta. So at this point, we can simplify the integrand, okay, and we can do some cancellation. Of course, we can cancel 4/3. We can also cancel secant of theta, okay. So what is left? We have the radical square root of 16 secant square of theta minus 16 times tangent of theta d theta. But we can still simplify the radicand. Okay, we have integral of, okay, look at the radicand, 16 secant square of theta minus 16. There is a common factor 16, right? So we can factor out the common factor 16, so that the other factor is secant square of theta minus 1, okay? Then we multiply this by tangent of theta d theta. But please take note that secant square of theta minus 1 is tangent of theta, okay? How is that, no? Okay, what is the identity? We have the identity that tangent square of theta plus 1 is equal to secant square of theta. Therefore, if we will transpose one to the other side of the equation, then tangent square of theta is secant square of theta minus 1. Hence, we can replace secant square of theta minus 1 in the radicand by tangent square of theta. Okay, so doing that gives us the integral of the square root of 16. Secant square of theta minus 1 is tangent square of theta, okay, times tangent of theta d theta. Okay, and the square root of 16 tangent square of theta, of course, is 4 tangent of theta. And we have 4 tangent of theta times tangent of theta d theta, in which we can write the constant factor for before the integral sign. And tangent of theta times tangent of theta is tangent square of theta, okay, d theta. Now, how do we evaluate this time the integral of tangent square of theta d theta? We need again to do transformation. Now, if we will do transformation, then we use the identity. The tangent square of theta is secant square of theta minus 1. So that this will give us 4 times the integral of, okay, tangent square of theta is secant square of theta minus 1 times the differential of theta, and expressing this as sum of integrals, okay, and distributing 4 gives us 4 times the integral of secant square of theta d theta minus 4 times the integral of the differential of theta. And we can evaluate now the integral. Okay, of course, the integral of secant square of theta d theta is tangent of theta. So integral is 4 tangent of theta minus 4, the integral of the differential of theta is theta, then we add the constant of integration. And at this point, we need to substitute back the original variable. Okay, now how do we substitute back the original variable? We need again to refer to a right triangle now using the substitution then, okay? The 3x is equal to 4 secant of theta. Okay, let me have it here. Okay, we have 3x is equal to 4 secant of theta. This is our substitution. Now, if we will divide both sides of the equation by 4, that will give us secant of theta is equal to 3x over 4. Okay, and we can refer again to a right triangle whose acute angle is theta. Now this time, secant of theta is 3x over 4, and by definition of the secant function, it is equal to the hypotenuse over the adjacent side. Therefore, the hypotenuse is 3x and the adjacent side is 4. Hence, if we will get the opposite side, then the opposite side is equal to the square root of the square of the hypotenuse. The square of the hypotenuse is 9x squared minus the square of the adjacent side. So that gives us the square root of 9x squared minus 16 as the opposite side. Now, what do we need? Okay, we need tangent of theta, right? So if we will get tangent of theta, then tangent of theta is equal to opposite over adjacent side. The opposite side is square root of 9x squared, okay, this is 9, no? Minus 16 over the adjacent side 4. We also need theta, so if we have secant of theta is equal to 3x over 4, then solving for theta, theta is equal to arc secant of 3x over 4. Okay, so let us now substitute back the original variable. Okay, integral is equal to 4. Okay, tangent of theta is square root of 9x squared minus 16 over 4. Okay, then minus 4, okay, times theta is equal to arc secant. Okay, we have arc secant of 3x over 4 plus the constant of integration. And simplifying further, okay, we can do cancellation here. Okay, we can cancel 4. And the integral is equal to the square root of 9x squared minus 16 minus 4 times arc secant of 3x over 4 plus the constant of integration. Okay, so I hope that you were able to follow the discussion on integration by trigonometric substitution.